Assalamu alaikum everyone, and today we are going to see the laws of exponents. Woo! Okay, so the law doesn't mean the law word you always use in your regular life. In math, laws are rules that can be applied to mathematical equations and problems. So if you searched laws of exponents online, or maybe in a math book if you have one, then you saw these list of equations, I think. Now these equations are actually very important. They look very confusing when just saw on a paper, but these can easily be explained and proved. The first two we already covered in my exponents in algebra video. Why x to the first power equals x, or x to the zeroth power equals 1. We already covered that. Link it in the description just if you want to brush up on that. So let's look at the third law. The law we haven't looked at yet. X to the negative nth power equals to 1 over x to the nth. So what it's telling us, if we take a number and put it to the negative nth power, we get 1 over x to the negative nth. We can see that because you can see that 2 to the negative third power equals to 1 over 2 cubed, which is 0.125. This law works in this actual arithmetic equation that we took from this algebra law. This can also be applied to some other equations. We will see those applications more on stuff like trigonometry or calculus or anywhere else, or even physics, chemistry, all those stuff. So let's look at the fourth law, the last one on this line. Let's give a tick mark so that we can keep track. So this next law, x to the n group, and the group is raised to the nth power equals to x to the power of m times n. This thing is a particular thing in exponents we call nesting. So x to the n is being nesting by the nth. So x to the mth to the nth, you can say sometimes, is equal to x to the m times n. You can see that I have this book here as always. So let's see that in action. X squared to the third. Remember, this is algebra. This is algebra class, so we are going to use the algebra applications mostly. So this practically will be x 2 times 3, which equals to x to the 6. Let's see this in action. X to the 2 let's see this in action. This particularly means x squared times x squared times x squared. X squared can be derived as x times x times x times x times x times x. So these are 6 x's. Wow! These laws do really apply. Okay, there has been a sound played. So if you can hear that, sorry for the sound. If you can't, why did I say that? Okay, so let's look at the next law. This time, we're going to see these as sets of laws. This is the first set because they relate. So let's see them in action. First of all, x to the m times x to the n. Let's say x squared times x cubed is the same thing as x to the 5th power. Now let's see this in action. X times x times x cubed. X, which can be simplified further, go on as x times x times x times x. So that's how you do it. Same goes for division. Division is repeated subtraction, so the same thing applies. Here, if we use something like x squared over x cubed, you would get something like x to the -1, and then use this law to finish the job. So the next set, again applying groups, we will see them as x, y to xy squared normally would be x squared times y squared. Let's see this in action. Now this would be the same thing as x times y times x times y. Using the commutative property, we can use x times x times y, because multiplication has the commutative property. In division, you can see this in action as well. This is just saying x to the y times x to the y, which is the same thing as x squared over y squared. So now we have all these exponents laws covered. Now I think you can use it in your mathematical equation. So thank you for watching, and I'll see you next time. Bye!